Good morning to everybody. Good morning. Thank you for joining us for our webinar, CSP, a partner for desalinizations. And thank you for being part of our second webinar of this year. Today, we're going to talk about how CSP could be the best partner for desalinizations. We're going to have 6 excellent exponents from USA, Spain, China, Japan, and France. And we want to be welcome to our audience from Chile, China, Japan, USA, Spain, Italy, Saudi Arabia, Morocco, and some other countries who are joining us today. First of all, we're going to receive the welcome words from Mr. Giancarlo Barassi. He's a director of the Desalinization Association, the name ACADE. Giancarlo, please.
Thank you very much, Cristian. Good morning, everyone. I'm Giancarlo Barassi, Director at ACADE and Technical Director at American Water Chemicals. On behalf of the Chilean Association of Desalination and Reuse, I would like to thank the Concentrated Solar Power Association for inviting our members to learn more about concentrated solar power technology in its various forms. This technology can significantly promote the development of energy generation, especially for desalination plants. As you know, at ACADE, we aim to drive climate change adaptation by developing seawater desalination and reusing wastewater to create new water sources for Chile. As an intersectoral guild, uniting companies from various fields and specialties, we aim to ensure that all people and all productive and industrial activities in Chile have access to water. Our doors are open for collaboration to reach the best solutions, which is why learning about CSP technology projects in particularly is very interesting now. Once again, thank you for the invitation.
Thank you, Giancarlo, for your kind words and for being part of us. As you mentioned, CSP could be a great opportunity for those desalinization fusion programs in Chile because we provide to our grid is flexibility, stability, and especially 24 hours available energy to everybody. In order to start it, we are going to give welcome to our first exponent, Mr. Johnny Liu. He is Director of Overseas Business Development from Cousin Solar Technology from China. Johnny, welcome to our webinar.
Oh, hello, everyone. Hello, all the patients online. Yeah, I'm very happy to be here today and also to be the first one to introduce Cousin Solar's the CSP and the desalination solution. So can you see my screen?
Yes, it's being seen. Yes.
Okay. I'm Johnny Liu, the Director of Global Business Development of Cousin Solar. So first of all, let me use several minutes to introduce Cousin Solar and our business. Cousin Solar, we were founded in 2010. We are technology provider and also equipment supplier for the tower CSP industry. We have mainly 3 business areas. The first one is the power CSP business. It could be single power CSP project or a hybrid project, CSP plus PV plus wind. This is the main business. And then we also have a molten salt storage business. For this part, we can use the molten salt electric heater to heat the molten salt, not to rely on the solar resource, not use the solar field. So it can be more flexible and deployed in more areas. And the third business is we can also provide the PV tracker. This is a new business from Cousin Solar. For the desalination, it's not our main business, but we do have some project to combine CSP, molten salt storage, and the desalination. So I will introduce in the last slide. Yes, this is all our product services. For the CSP part, we can do the system engineering. We can provide the equipment, the solar field, and we have our own molten salt electric heater, and we also produce the PV tracker. This is the Cristian Solar project reference. We have 3 projects in operation, totally 110 megawatts, and thanks to the Chinese government's policy for the CSP development in the last 2 years, we were awarded 11 new projects, totally 1,250 megawatts, and all these 11 projects now are under construction. These 3 projects is our project in operation. The first one, the 10 megawatt, it started running in 2013 with the directly steam. And in 2016, we modified one of the 2 towers to molten salt storage. And then we have another 2 projects in 50 megawatts level connected to the grid in 2018 and 19. And yeah, the next slide shows all our new projects under construction. All these projects are the hybrid project. CSP works as a storage and the peak regulation for the hybrid project. We have most of the project are 100 megawatts, and also we have 200 megawatts Dalinha project under construction. This one is the biggest CSP molten salt tower project, yes, in the world. And we have also a Hami 150 megawatt project. So Cristian Solar now, we are the company has the most projector reference in the molten salt tower sector. Yes, I would like to highlight the Dalinha 50 megawatt CSP plant. It was connected to the grid in 2018, and it was designed with 7 hours molten salt storage. This project, this 7 hours means it will run in a day, and after the sun sets, it has a capacity to run 7 hours at 50 megawatts. This is the site picture. And for the last 2 years, yeah, this project has been running more than 100%. So it's a very good performance. So for us, the CSP and power CSP is already a reliable and a proven technology. Okay, so I will introduce our some works about how to combine CSP and desalination technologies. The first, I would like to introduce a project. It's a Sangzhuo project in Australia. Actually, Cristian Solar, first, I want to explain. Cristian Solar, we don't have any works in this Sangzhuo project, but it's a very typical and very good project to combine CSP and desalination. This project is operated since 2016, located in the Porto Augusta. It's the South Australia. This project is about 30 kilometers away from the sea, and it has 3 sectors. One is CSP, not with molten salt. They produce the steam and hot water, and then they use the hot water and the MED technology to desalinate the sea water to to get the fresh water. Yes, they also have a reverse osmosis for backup. And then when they get the fresh water, it's used to grow tomatoes. They have 200,000 square meters the greenhouse, and so every year can produce. Oh, sorry, it produce huge the amount of the tomatoes. And this project is a commercial project, and also it works very nicely and very profitable. And so when it comes to Chile, in the north part of Chile, and we think we can refer to this concept of Shandrop project and to develop a circular economy project, and also put more technology into this. In the north of Chile, we have the best level of the solar resource. The DNI is from 2,400 and up to even 3,800, and also have the very big area for the free land. And this kind of a circular economy project, can be located on the close to the shore, just like the Shandrop project. And some areas, the DNI is also more than 2,400, and so we can use the CSP and also MED the technology, and also some we can also combine with the reverse osmosis to desalinate the seawater to get fresh water. So this water can be used for the agriculture, and also can for the fish farming. Actually, the solar resource in the north of Chile is very good. It's not only good for electricity. It's this temperature and also the dry weather is also good for the growing of the tomatoes, for all the and other products. Normally for a water desalination project, it has a challenge. It takes a long time to get the permit, and so there's also a new business I put here is for the sea salt. We can produce the sea salt from the seawater, and actually we can take the water and desalinate and to get all the water and all the minerals. So we cannot inject the concentrated seawater back to the sea, and so we can separate the minerals and get the very high quality sea salt and for the daily use. This is also a new idea for the desalination of the seawater. And also in Chile, in the inland, not the shore, that area, it has many salar. This salar can produce lithium, can produce many other chemical products. And now normally they use the natural evaporation to get more concentrated brine and the product. But we can also use the CSP and to desalinate this kind of salar and to recover the water. And it's also very good for the environment protection. And for this kind of circular economy, actually we can also combine with other technologies like hydrogen, ammonia production. So it can be as more technology work together to have the maximum efficiency and economical returns of the system. Okay, today the time is limited, so I can't go to many details. This is just the concept, and we have some research and some work about this circular economy project in the north of Chile. So after the webinar, yes, I'm happy to answer more questions, and if someone is interested. Thank you very much. Yeah, everyone.
Thank you, Johnny, for your excellent explanation regarding causing solar and how could be used right in Chile, especially. To everyone who is joining us after this webinar, all the PPT will be available in our website. Okay. Thank you, Johnny. Our second speaker will be Mr. Borja Navarro. Borja, are you there?
I'm here, Cristian, sorry.
Okay, welcome and thank you for joining us. Mr. Borja is from Cox Abengoa, Spain. He is the Director of Business Development. Thank you for joining us to be part of the webinar, Borja.
No
So
problem.
the screen is on yours.
Okay, let me share the screen. I don't know if you can see my screen already.
Yes, yes, can see it. Yes, no problem. Go ahead.
Okay. So first of all, Cristian, thank you very much for the invitation to the association for the invitation to participate here in this webinar, to all the attendees for showing interest on the matter. So thank you for that. As Cristian mentioned, I'm Borja Navarro, in the BD, the Business Development Global Director for Cox Energy within the Cox Abengoa Group. And I will spend like a couple of minutes, 3 minutes to explain, because I understand that most of you know the Abengoa and the Abengoa legacy and how is structured now the new group of Cox Abengoa. No? So very quickly, the new Cox Abengoa group is a combination of Abengoa, the traditional Abengoa, very involved and deeply involved in both of technologies now that we are speaking about today, not just CSP, but also desalination. So now we are integrating both companies and creating a new industrial group. So as I mentioned, global group doing different technologies with different verticals, business integrated in different, business unit, but with a very strong legacy and experience and references, not just in CSP and power generation, but also in desalination plant. And as you well know, we are covering the whole value chain of a project, from the development standpoint, and depending on the technology and depending on the geography, we do our own, concession and development, but also very, very focused basically in EPC and operational maintenance. And as you know, we have, in terms of references, and you can see here, the Cox Energy and the Cox Abengoa Water, the two first divisions and verticals that you can see in the screen. There are the two ones related to the topics today. So as a CSP expert, more than 30 plants around the world, in South Africa, USA, Chile, Emirates, Algeria, Morocco, Mexico, China, even Saudi, almost 2.4, 2.5 gigawatts of CSP installed around the world. And at the same time, within the vertical of Abengoa Water, more than 4 million cubic meters a day of the salt plants around the world as well, with more than 30 references. And the first one, I think, that installed back in the 70s, last century. So, I think that we are a very, well-known, experience and with a lot of reference in these two technologies. So I think that it's not worth to say that we are a CSP and desal lovers. We want to especially in CSP, because we are already developing some desalination plants around the world, but it's worth to mention that we want the CSP back in the market again. And just to show you some of the experiences and references around the world. Well, in the US, in South Africa, you are familiar with the technology, you know all these plants. At the same time, also in desalination plant, well, around the world with more than, again, 30 references in desalination. So again, we want to see the CSP back in the market. We see that in some of the countries they are betting again for the CSP, and I think that the exercise that you, Cristian, mentioned in your invitation, in your mail, how we can integrate both technologies and how to do it off grid, standalone basis with a specific consumption and a specific capacity of plant, how they can work together. I think that is an outstanding strategy, and again, we want to work from not just from the EPC standpoint, that is where we feel comfortable, but also from the customer, developer, utility, IPPs, and I don't know, ministry level, and I think that is an important bet. I think that with having said that, well, for me, the exercise that we need to do, and I'm not gonna go point by point here in my presentation. I will leave you to read it, and we will share the presentation with you. But I think we are very aligned with my good friend Johnny before from COSIM. I think that, again, while we agree on the combination of both technologies, I think that the important exercise that we need to do somehow is related to how to dimension and size and design that combination, especially the CSP. This concept of off-grid CSP, full dedicated to desalination, I think that in order to make the most of the power generation, to make the most of the again, the technology, the capacity, the investment has to be, well thought and well designed in order to make the most of the capacity. Again, I think that with all the parameters, especially in Chile, and well, we can see that we have it's a remote location at high DNI with a very strong pumping needs. We need a reliable, we need a manageable, dispatchable energy. We have storage. We can solve the problems that we have with other different technology, like a PV or like other power generation. So let's think about how we can optimize the size of the CSP plant, because again, we can use it for different purposes, as Johnny mentioned before, agriculture, multi-PPA for different mining or different services that we can provide, and we can create energy communities in order to, again, to make the most of the capacity and the investment of the CSP, and create, again, the good view of the technology among the community, among the government, about the different players participating on this. So again, my strategy and my point to brainstorm is that we need to go to CSP plant, not just for the desalination plant, because again, as you can see in the case of a study that Cristian mentioned, well, it's a good size, but we see that we can optimize much better the standalone storage or the power generation in general if we put together more services, if we put together more consumption, if we go to bigger plants with the problem of the financing, with the problem of different things that we need to permitting and so on. But let's try to get into a compromise situation where the plant is big enough to cover the desal, to cover the pumping, to cover more services, to cover the community consumption, agriculture, fishing, whatever we need to put together to create an environment where the CSP is accepted again, is beneficial for everyone, the economics somehow work, and this technology has to be in place again and beneficial for everyone. And so again, that's my point. I'm not going to enter into details of numbers and so on, just as a concept. But again, very aligned with the concept that Johnny mentioned before. I think that we need to go to wrap up something else about a part of the desalination and create the environment for the CSP. So, Cristian, that was my presentation. Open to
Excellent.
questions.
Great. Many thanks, Borja, and it is a pleasure to see how one of the big CSP player as Abengoa is going back to the business, and welcome back. Okay.
We never left the business. we were hiding, but
Yes,
you know,
yes.
you know, we
And
are
thank you so
are
much. Thank you so much for your interesting presentation. We know that it could be a long time that CSP could be workable for agriculture, for desalinization, for ammonia, for many different purposes. And to all of our attenders via YouTube, you can also write some questions that are going to be shared in our final at the end of the webinar. It will be handled by Mr. Frank Dinter, the General Manager of Fraunhofer, and also is the President of ACSP Board of Directors. He will handle the Q&A section at the end. So thank you again for your time. Now we are going to welcome Mr. Masaki Okabe for AGC Japan. Mr. Okabe.
Okay, thank you. I'd like to my presentation. Okay.
Welcome, Mr. Okabe. Thank you for joining us. Mr. Okabe, here from AGC Japan. He's Dr. Mr. Osake Okabe, professional for Sustainability Division, Corporate Planning, General Division of AGC Glass Company in Japan. Welcome, and the screen is yours.
Thank you very much. So introduction. Can you hear? Can you see my presentation?
Yes, absolutely. See, so no problem.
Okay, thank you very much. So thank you very much for invitation, and so thank you very much for joining distinguished attendees. So my name is Masaki Okabe from Tokyo, Japan. I'd like to make a presentation about innovation of CSP glass for desalination process. So before start, I'd like to introduce my company, basic information of AGC. So AGC is established in 1907. That means more than 100 years ago. AGC is the first company to produce glass in Japan. And now we are number of consolidated subsidiaries is around 2,000. But unfortunately today, we have no office and no factory in Chile. Maybe so, I hope so soon. So AGC is position is here, and so AGC starts business about manufacturing glasses, glasses for building, for automotive, for smartphone, laptop, and so on. Now we can we expand our business not only glass, but including the chemical and ceramics and bioscience. So to for my presentation, I already said CSP applications. So we understand desalination process is also including the CSP applications. So CSP can contribute to desalination by renewable energy instead of fossil fuel. It is very, how to say, political driven as of so now under the Paris Agreement. So I'd like to about some technical point. So this is a required performance of for CSP glass. There are mainly three parts. One is glass surface, including durability, surface flatness, and anti-fouling. So secondly, glass material, so including transparency and lightweight, especially for solar tower, for tracking. And thirdly, so mirror surface, including durability and reflectivity. Now, we AGC can carry out R&D from the beginning of CSP. So summarize, so required performance for CSP glass is transparency, reflectivity, flatness, and almost durability, lightweight, anti-falling. So this means innovation required. So today, time is restricted, so I'd like to mainly to point transparency and reflectivity. So regarding reflectivity, education improvement is by coating technology. As you know, so red line is with coating, and so black line is without coating. So around 1 or 2% education is improved by coating technology. And also, thickness and transparency is very, how to say, good combination. As you can see, so blue line is 1 millimeter thickness glass, and so green line is 1.8, almost 2 millimeter thickness. And so red line is 3.9 millimeter, almost 4 millimeter thickness. So now we can now making some R&D for blue line, so like 1 millimeter thickness glass for CSP. It is a cutting edge technology. I'm very happy to collaboration with Terra Engineering in Spain. So we can make prototype of CSP mirror with only 1 millimeter glass. That means how to say high transparency, and also the material is also saved because the glass is also limited resources. It is good for circular economy. Now we would like to this cutting technology to CSP for desalination and the other project. So last my slide is not technical but finance. I'd like to very briefly about basic concept of the joint credit mechanism, JCM, because JCM is also supported by Japanese government and under discussion of UNSCC. So I'm now in Germany, Bonn, to attend UNSCC meeting. So there are many discussions about mitigation, adaptation finance, and so including the Article 6, that means so related with JCM. I'd like to more explain about the next slide. This is the contribution from Japan example. So it's very, how to say, briefly speaking, so Japanese government will finance support to new project. And if, how to say, we can get some emission reductions, so Japanese government would like to get this emission reduction as a CO2 credit. So this is how to say Japanese finance support, very, very simple structure. And so of course, this is to utilize JCM, we need some two countries assignment. Because fortunately, Chile is also signed Japan in 2014. So there are many projects in Chile, but not only no CSP, no desalination plant. So if you are interested in this scheme, please contact me freely. So AGC would like to contribute not only technical but also finance for CSP for desalination. So thank you very much.
Thank you, Mr. Okabe, for your excellent presentation. To our audience, let me tell you a little bit more about Mr. Okabe. Also, Mr. Okabe is a well-known person, international for environment agreement. He's in Germany right now. He usually travels worldwide, represented the Japanese government in France, in COP, on everything's when in every international seminar or any international agreements be signed by the environment, Mr. Okabe, Dr. Okabe is being involved. As he already mentioned, this could be very important. Maybe after this webinar could be contact Mr. Okabe, the GSM subsidiary from the government of Japan which is looking for the reduction of CO2 and NOx, no, just CO2 emissions. So that would be very interesting because they could be finance some future project, especially for desalination or for other projects. So, Mr. Okabe, thanks again for your time and for your excellent explanations. As I remember, we would like to say it again, you can share your questions in our YouTube channel in order to be replied in our Q&A section at the end of the webinar. Right now, let's welcome Mrs. Carla Barrera, sorry. She is from LSB New Energy. She's Energy Storage Global Business Development and Market Director from France. Carla, are you there?
Yes, I am here. Thank you for the introduction, Christian. Thank you for the
Welcome,
invitation
and your
as well.
screen is yours.
Thank you. Let me share.
Okay, it's looking good.
Okay, let me go to presentation. How can I, okay, sorry. Display settings and swap. Here we are. So again, thank you for the invitation. It is a real pleasure to be here. Thank you to ACSP y ACADES. I am Peruvian, so grew up in South America, very close to Chile. I am based in France, as you already said, for the last 7 months. I was living in Houston before. With the job at SLB, 18 years with the company, I tend to move around, but it has been a very interesting journey. So again, my pleasure to be here. During this presentation, what I would like to do is to cover a little bit about SLB and the New Energy Organization, and also then deep dive more into the energy storage business, which is the business I am in, and to showcase the innovative hybrid technology that we have that combines solar and thermal energy storage. So SLB, for those who are not familiar with the company, we used to be called Schlumberger. Maybe that rings a bell more. We are a technology company driving energy innovation for a balanced planet. So that is our raison d'etre. We are almost a 100-year-old company, so similar to the previous presentation that we heard. And we have been known as the oil field services leader worldwide all these years. But we have evolved and we have rebranded in 2022, and now we are called SLB. Our new logo, as you can see there, was created inspired by the carbon budget curve to remind us of the importance to achieve net zero and all that has to be done for a sustainable and balanced planet. We are an organization with a long history of technology and innovation since the very beginning. We have been growing organically and inorganically along the years and have an unmatched global footprint with more than 100,000 employees. We have presence in 120 countries, and we have more than 90 technology development and manufacturing centers in the world. SLB focus is on sustainability and reducing emissions and helping our customers do the same, contributing to accelerating their decarbonization journeys to achieve net zero. With that in mind, as you can see here on this slide, 5 years ago, we launched our New Energy division, and the organization has 5 key focus areas. There is carbon solutions, which is namely carbon capture, storage, geothermal power and geoenergy. So geoenergy means shallow geothermal for building heating and cooling. We also have critical minerals, namely lithium. We have a proprietary direct lithium extraction method to extract battery-grade lithium. And of course, we know Chile is a great market for that. clean hydrogen, which is both blue and green, if we want to mention the colors, and energy storage, the business that I am representing. Sorry, doesn't go. Oh, here. Okay. We do not need to go into too much detail here, but this is just to highlight the market drivers for storage. That is the acceleration of renewable energy to replace fossil fuels, the increase in electrification, electric vehicle adoption, and decarbonization in general, as well as the supportive policy that we are seeing, right? These drivers really increase the need for energy storage. And as you can see in the graph on the left-hand side for you, as the variable renewable energy penetration increases, so does the need for longer duration storage. So more penetration, more percentage of variable renewable energy, the duration, the number of hours that you need also goes up. And you're moving from grid support and grid flexibility all the way to grid resilience, where obviously long duration energy storage going into seasonal is becoming paramount. We understand that Chile is already seeing the need for 5 hours plus of storage, and clearly this trend will continue to increase rapidly. I am now going to jump directly to the technology, as we believe that it is really ideally placed to support desalination processes, but also other energy-intensive industries with needs for 24/7 baseload. So I think my fellow panelists here have really explained very well the need, right? The business case for that. And the technology that I will be talking about is a hybrid solar plus thermal storage, which SLB is bringing to the market in partnership with Reunión. Reunión is an Australian technology company that developed this technology. Let me give you a quick high-level view of how the technology works. It has mainly two parts, as you can see here. One is the generation part, intermittent solar, and the other one is the storage part, the dispatchable storage. So you have a set of mirrors. I mean, everybody's very familiar. This is not exactly CSP, but it has some of the elements of it. There is the sunlight that is focused on the photovoltaic modules into the receiver here, which then convert the light into electricity and heat. The electricity can be directly exported to the grid, or it can be used for the chiller to charge the storage. The PV Ultra modules get hot under concentration, of course, and are cooled at the back part with water. And then we capture that waste heat to charge the storage as well. So we have two pits, right? The hot and the cold one. Water is our storage medium contained in these two reservoirs. The hot pit is charged by the heat coming from cooling down the modules, and the cold pit is charged by the electricity from the modules or from the grid. And it's the temperature difference that makes the two storage pits spin the organic Rankine cycle engine that provides the dispatchable electricity. Let me talk about the part of the harnessing sunlight first. I'm just splitting this into 4 parts. So the field of mirrors focus the sunlight onto a tower that has a photovoltaic receiver. The mirrors are low cost. They are made of simple materials, mainly glass, steel. They are low complexity and don't require any foundations, which is a big advantage. They are self-powered. We don't need any wiring. The mirrors also have a small PV and a battery to track the sun throughout the day, so they can self-calibrate to find the receiver without any encoders. The mirrors are suitable for agrivoltaics as well. As you can see in the photo here, they are elevated off the ground and they move dynamically, avoiding fixed shading and increasing feed growth as well. At the top of the tower, we have the solar modules that generate electricity and heat. The PV Ultra modules are only 10 by 10 centimeters. They fit into your palm, as you see in the photo, very, very nicely done. and they generate 2.5 kilometers of electricity and kilowatts, I'm sorry, generate 2.5 kilowatts of electricity and 5 kilowatts of heat. 2 of these are as powerful as a whole rooftop of solar and hot water. We are converting light very efficiently because we're not using polysilicon. We use triple junction cells that have been used in space. So they are very, very powerful, and they grab twice as much sunlight as traditional silicon. These modules, which is really the IP of the technology, are manufactured in Australia. Again, no polysilicon is being used, and so there is the risking of the supply chains. When it comes to the energy storage part, we are using the lowest cost of storage medium, which is water, making the long duration storage low cost, low risk, and very efficient. So as I was mentioning before, we have these 2 reservoirs of water, one heated to 90 degrees, and the other one is cooled to 0 degrees. We fill up the pits only once, and there's hardly any water being lost during the operation. They also can hold the temperature for months. As you can see here, they are very efficient. They just have low-cost rubber insulation. The depth is around 15 or 20 meters. And they can hold a temperature for months with less than 10% of energy being lost over 6 months. Therefore, they can be also applicable for seasonal storage. Regarding energy dispatch, we use widely established technologies to dispatch the energy or to act as a load. For example, the pit thermal energy storage, which is used in district heating in Denmark, Germany, and also the organic Rankine cycle that I mentioned before, which is an engine widely used in geothermal applications. It provides the thermal energy by a heat exchanger to evaporate the ammonia in a closed loop system. The ammonia is really the fluid that runs the engine. As the ORC is a high-speed turbine using low heat temperatures, it takes less than 5 minutes to ramp up for cold and can respond within 6 seconds when it's on. So it's very, very fast. Another important thing to mention is that net electrical round-trip efficiency of the system. This is at between 70 and 80%, which is very, very high for this type of system. Very efficient when you get the free heat from the modules. And you can have a slight decrease in the efficiency, of course, if you use heat pumps. But overall, we are at between 70 and 80%. Let me take a look here at the integration of renewable energy for desalination. We have seen here from the previous We have seen from the previous presenters as well about the use of PV and reverse osmosis, which is really the most common. It has been done, I think, cost efficiently in small scale, but we still need to get there at a larger scale and being cost efficient. I have read about other cases using wind and also using CSP, as we have heard as well here. But the challenges remain, the challenges in cost, the challenges on the environmental impact. And of course, renewable energy is intermittent by nature. So the lack of continuous supply is always a problem, for which long duration storage is really mandatory to be able to address desalination. For RayGen use cases and value propositions, we have mainly 2. And we have several use cases as well as revenue streams. But let me focus on the one that is applicable for the purpose of this presentation on desalination. So baseload for large energy users aiming for reliable generation and to minimize energy costs, as is the case here for desalination plants. We work with large energy users like mines, green hydrogen, ammonia plants that have very similar needs as desalination plants to provide 100% baseload capacity. This system can be sized to ensure the adherence exclusively with the system or it can also be paired with other alternatives. And also you can add other loads. Also the solution can act as a load and absorb excess clean energy in and around renewable energy zones or hubs. And it is also well suited to be paired with wind and traditional solar PV in order to increase the capacity factor as well. Further benefit is that having a constant baseload power allows for continuous operation of a desalination reverse osmosis plant from a renewable source of energy. And this, we understand, improves the lifespan of RO membrane. They typically prefer constant pressures and rates to maintain the constant selectivity. I think there are many other things to discuss. In the interest of time, I will be very happy to continue having these discussions regarding the specific advantages that our technology can provide for a more energy efficient, lower CapEx and OpEx and sustainable desalination process. Our core business within SLB can also serve the desalination industry with efficient horizontal heat pumps, valves, and pipelines integrity monitoring. And as I said before, you will have my contact details. If you need more information, we are happy to have side discussions in more in depth. To wrap up, I just want to leave you with our flagship project in Australia, in Carwarp. As you can see here, this is close to Mildura in Victoria, for those familiar with Australia. It is demonstrating that our technology works and obviously can be commercialized. At the moment, this is a 4 megawatt solar, but 50 megawatt hours storage. So that's 17 hours. So that is a very important, one of the largest next generation long duration energy storage technologies that is operational at the moment. It is also the highest efficiency operating utility scale solar PV project. And another project in the making is Yatnari in South Australia that demonstrates how our technology can scale up and be deployed at utility scale. This project is 150 megawatt solar, 1.5 gigawatt hours storage for a 12-hour plant. You see here what are the target dates for financial close. So we are working very hard on this other project in Australia. And the focus really now is on deploying this technology internationally. And we believe that Chile, as in agreement with my fellow panelists, offers the best DNI, the best resource quality overall in the world, and also has a critical need for such systems and other CSP systems as well. There's no one silver bullet, of course, but not only for desalination, but also for the other great industries in which Chile is leading and needs 24/7 baseload, such as mining, green hydrogen, ammonia, and where Chile is having a really protagonist role in the world. This is the end of my presentation. Thank you for your attention.
Thank you, Carla, very much for your excellent presentation. It's very good to see how your technology could be scalable from a small project to a big project. Could be for desalination, mining, ammonia. It doesn't depend of the future user. And thank you very much. And I know that your PPT will be available in our website. Thank you.
Thank you.
So continue right now. Let's move to USA. We are going to start with Mr. Jose Hernandez, Director Commercial of Latam from Elogen. Jose, are you there?
Yep, I'm here.
Okay, the screen is yours.
Okay, thank you. I'm going to do my presentation in Spanish. I know we have a combination of a variety of audiences, so we prepared ours in Spanish for the Spanish-speaking audience members. So
no problem. No problem. Go ahead. There's no problem because we have a variety of audience, and after that, if anybody in English would want to contact you, we will share your presentation in English to them. So no problem. Go ahead. Good luck.
Yep, no problem. And we're happy to take them, take them in both. So no problem. So okay, just let me know when you can see the screen, and we'll get going.
Yes, go ahead.
Okay, perfect. So I'll just quickly start by saying that unlike a lot of our panelists, Heliogen is still a relatively small company. We've only been around for about 10 years, and we kind of see ourselves as a technology company. So our focus is decarbonization and how we can do that with CSP technology. And so with that, I'll switch, and then we'll get into the presentation. So bienvenidos a todos, gracias por estar con nosotros. Estamos felices de poder presentar con ACSP y ACADES para este panel. Así que muchas gracias por estar con nosotros. Como les comentaba, Heliogen es una empresa relativamente joven, una empresa pequeña, somos como 120, 130 personas nada más, pero estamos enfocados en cómo podemos descarbonizar la industria utilizando CSP. Entonces, la presentación hoy es cómo podemos utilizar nuestra tecnología de Heliogen como un complemento tecnológico para la desalinización. ¿Sí? Bueno, lo que ven aquí es una gráfica, una esquemática de uno de los diseños de nuestras plantas. Y lo que nosotros hacemos un poco de diferente o de otra manera a las empresas tradicionales de CSP, o lo que se ha hecho históricamente, es reinventamos, tratamos de utilizar la tecnología para traer lo que es CSP pues al año 2024, ¿no? Estamos utilizando inteligencia artificial, almacenamiento térmico, para poder entregar vapor, generar electricidad, o para también consumo y uso en procesos industriales, ya sea desalinización, hidrógeno verde, otro tipo de gases renovables, gasolinas. Entonces, nosotros utilizamos la tecnología de un poco de otra manera. Entonces, creo que acá en la siguiente slide podemos ver lo que nosotros hacemos. Entonces, generamos básicamente tres tipos de opciones, ¿no? Tenemos la opción de calor, que es convertir la energía de CSP en vapor para procesos industriales, ya sea a alta presión o baja presión, y se puede utilizar para la industria minera, petroquímica, proceso de alimentos, también para las plantas desaladoras. Ese mismo calor se puede utilizar también para la generación de electricidad, utilizando vapor, y una turbina de vapor, y utilizando también combinando la energía de CSP con todo lo que es el almacenamiento. Entonces, utilizando estas dos en combinación, también se puede utilizar para generar hidrógeno verde, como bien comentado en las otras presentaciones, y otros tipos de combustibles, pero libres de carbono, ¿no? Que es, creo lo importante donde va toda la industria. Entonces, ¿cuál es la manera en la cual nosotros estamos tratando de reinventar esta tecnología? Es, obviamente, lo más importante es los costos competitivos, porque ningún cliente, ninguna industria son muy pocos los que están dispuestos a pagar de más. Entonces, para nosotros es muy importante que los costos que estamos presentando para nuestros clientes sean competitivos, ¿no? Entonces, el diseño, el approach que se está haciendo para el diseño de las plantas, la arquitectura y la tecnología en sí es enfocada en los costos competitivos. Luego también el factor alto, ¿no? Como comentaban anteriormente en el panel, las plantas desaladoras necesitan energía 24/7. Entonces, para nosotros el diseño que tenga el almacenamiento de 16, 18, 20 horas es muy importante. Entonces, tenemos varias opciones para diseños híbridos que utilizan fotovoltaicos, también se puede utilizar gas si es necesario, o energía de la red, para asegurar el suministro de la energía 24 horas al día. Lo otro también es, nosotros normalmente para la torre, las plantas de CSP de torre central, pues se requiere mucho terreno, ¿no? Y para nosotros, creo que cuando estábamos estudiando los diseños, diferentes opciones, pues aterrizamos en el diseño modular. ¿Por qué? Porque es una manera de poder incrementar el tamaño de las plantas poco a poco, ¿no? Ir creciendo como va creciendo la necesidad, o lo que es, o sea, un poco diferente de tener que hacer una planta de 150 o 100, 200 megas, ¿no? Entonces, para nosotros esa parte es muy importante y pues el desarrollo, el diseño y el trabajo de ingeniería que estamos haciendo con nuestros socios es enfocado en el diseño modular. Y la última parte es la manufactura, ¿no? De tecnología. Entonces, el diseño de los heliostatos, el proceso de instalación, todo eso se hace en plantas altamente automatizadas que se pueden replicar en otros países, ¿no? Entonces, ahorita nosotros trabajamos más que nada en Estados Unidos porque la empresa está basada en Estados Unidos, pero tenemos una presencia grande con oportunidades, proyectos y estudios de ingeniería que estamos trabajando para proyectos en México, proyectos en Chile y también para proyectos en Australia. Bueno, esta creo ya la cubrió Johnny, ¿no? De COSIN durante su presentación sobre la irradiación directa y por qué es tan importante Chile, pero creo que para mí lo importante de recalcar es que esta zona de la parte norte del Chile, en donde el DNI es altísimo, pues da el beneficio de que está cerca también de las zonas mineras, ¿no? Y sabemos que el gobierno de Chile, con la legislación que están pasando ahora, pues el cambio de consumo de agua va a ser muy importante, ¿no? ¿Por qué? Porque las mineras consumen muchísima agua para su proceso. Entonces, lo que son las plantas desaladoras, pues va a haber una explosión. Nosotros queremos una explosión de crecimiento y de plantas nuevas en esa área por lo mismo de que las zonas mineras requieren tanta agua para su proceso. Entonces, es una combinación donde se dan todos los factores, ¿no? Está el agua disponible, están cerca del mar, está la radiación altísima y está también la zona o el clúster de clientes que necesitan el suministro en altos volúmenes, ¿no? Entonces, creo que para nosotros es muy importante trabajar en Chile por las oportunidades que hay con los mineros, con el clúster de diferentes clientes y también pues el trabajo que está haciendo el gobierno, ¿no? Y la legislación para cambiar el consumo de agua. Pero creo que lo importante, lo que todos quieren ver o conocer es una esquemática, ¿no? Del proceso. Entonces, para nosotros, nosotros como empresa de tecnología, empresa todavía un poco joven, ¿no? Que tenemos solamente, creo, llevamos 10 años, tenemos un grupo y un centro de investigación y desarrollo de tecnologías. Y parte de lo que estamos trabajando ahorita y estudiando con un cliente es cuál es la arquitectura o la esquemática que más beneficio tiene para las plantas desaladoras y cuáles tecnologías, ya sean las de RO o las térmicas, son las que más fácil se pueden integrar con CSP y cuáles tengan las sinergias que le den valor a la planta, no nada más en términos de ingresos, pero sino en términos técnicos también, ¿no? Entonces, para nosotros el diseño básico que tenemos es una planta híbrida de fotovoltaicos con CSP y almacenaje, usando sales fundidas. Entonces, con este proceso generamos vapor y también energía. Entonces, acá en la gráfica al lado derecho tenemos pues las dos opciones, ¿no? Ya sea la desaladora que consume muchísima energía. Entonces, con este tipo de planta empezando en 50 megas, pero que es escalable modularmente de 50, 100, 150 hasta 250 megas, se puede generar energía para la planta desaladora en las 24 horas al día. Entonces hay diferentes opciones. Ahora para las desaladoras que utilizan el proceso térmico o el FO, pues aquí como ven en la gráfica, lo que se provee para la planta son dos cosas, ¿no? El vapor para los procesos térmicos que se utilizan y también la energía para el consumo de la planta. Entonces, para nosotros lo que estamos estudiando es más que nada cómo se puede integrar nuestro diseño a las desaladoras que utilizan el proceso térmico. Y es parte de lo que estamos investigando como empresa para tecnología que podemos presentar al mercado, pero también con nuestros clientes que están interesados en esta tecnología y que quieren desarrollar en conjunto con ellos y en la tecnología de CCP para implementarla con las desaladoras de proceso térmico. Pero creo que el enfoque para hoy no era el beneficio de la integración de CCP con las plantas desaladoras. Entonces, traté de hacerlo lo más corto posible porque solo teníamos 10 minutos. Pero pues creo que aquí tenemos lo más importante, ¿no? Lo que es la flexibilidad y la capacidad de integrar los sistemas de generación con distintos procesos, sea el RO o el proceso térmico, que la energía es despachable. Estábamos en el panel, creo que en la presentación anterior, sobre el consumo de energía que tiene que ser anivelado a las 24 horas, pues al tener el almacenamiento térmico, se puede generar la energía de ambas maneras, ¿no? Y lo más importante, que es libre de emisiones. Lo otro importante, y creo que esto es un problema que tenemos en muchos países desarrollados o países que se están desarrollando también, ya sea Chile, sea México, sea Estados Unidos. La red está sufriendo mucho, ¿no? Por diferentes problemas. Entonces hay problemas de congestión, hay problemas de interconexión, y también los costos de conectarse a la red son muy altos, ¿no? Entonces lo importante de este tipo de planta, o una de las cosas importantes de este tipo de planta, es que puede ser abasto aislado, ¿no? Entonces se puede diseñar la planta y localizar la planta cerca de una desaladora, cerca de una minera o dependiendo del cliente, y no hay necesidad de estar conectados a la red, por lo mismo de que se puede generar las 24 horas y pues reducimos la dependencia de la conexión con la red y los problemas que ahorita estamos sufriendo, ¿no? De intermitencia, de estabilidad. Entonces creo que eso es muy importante como uno de los beneficios de CSP con las desaladoras. Bueno, y creo que lo último para mí sería, creo que lo importante es que esta tecnología es modular y es escalable, ¿no? Entonces, no todas las desaladoras van a consumir 100 megas o 200 megas. Entonces, al poder empezar un poco con una planta más pequeña de 50 megas o 40 megas, pues se puede escalar al tamaño adecuado. Y creo que los dejo con lo último, que nosotros como ellos tratamos de diseñar cada planta como si fuera un traje a la medida, ¿no? Cada cliente va a tener un proceso diferente, va a tener un diseño de planta diferente. Entonces nosotros diseñamos nuestra tecnología y nuestras plantas para integrarse con la de los clientes, pero pues muy detallada, ¿no? Para que sea a la medida de la línea de consumo, ¿no? Entonces, pues muchísimas gracias por estar con nosotros y por escucharnos, y cualquier pregunta, pues aquí estamos para contestarlas.
Thank you, Jose, for your time. Yeah, you're right. You mentioned our problems, especially in Chile, the curtailment. The curtailment on transmission line is a very, very complicated problem. Right now, we are losing around more than let's say it's 2,500, 2,800 mega in the north side of Chile per day because of the curtailment. So a small CSP could be the solution, not connected to the grid. So less cost from the system, no transmission problems. So that's the idea. In order to thinking how the CSP not connected to the grid could be the solution for this kind of problem. So thank you very much for your presentation, Jose.
Yep. You're welcome. And I'll end with this, that in some areas the costs are as high as $30 per megawatt for transmission, distribution. So it's substantial enough that it affects the companies and the projects returns. So thank you.
Right. No problem. So last speaker will be our friend, Mr. Bruce Anderson, CEO from 24/7 Solar. Bruce, are you there?
I am here.
Welcome, Mr.
Yeah.
Thank you very much for joining us, and the screen is yours.
Well, this has been a great morning already, just really extraordinary. So I'll say buenos dias.
Buenos dias.
Ni hao. Bonjour. And Ohio gozaimasu. I think I've covered everybody. Let me share my screen.
I think you did. Yep. Okay, we can see it.
All right, good. So we're a company, we are a technology company, but we actually sell our electricity and our heat, in this case for green clean water, desalination, water purification, and so on. We are a young company, spin-off from MIT, and we are looking for partners to produce clean water for sale, green hydrogen, clean electricity and heat. So we leverage our unique proprietary technologies that operate 24 hours a day, year-round. We have over 30 patents. And what we do is we design, leveraging those technologies, we design, build, own, and operate clean energy systems and sell round-the-clock clean electricity, process heat, water, and hydrogen for a wide variety of customers, especially industry and utilities. And we don't get involved in a project unless we can reduce energy bills by 25% and eliminate CO2 emissions. Here's our unique technology. One breakthrough technology is our solar receiver, a standard module that sits on top of a 35-meter tower and heats air to almost 1,000 degrees centigrade. And then we can store that heat fairly cheaply for long periods of time. And we store it in pebble bed-like containers using blowers and dampers to move the air through the system. And I want to emphasize that the air in our system is at ambient pressure. It's not under pressure, it's atmospheric pressure. And the only moving parts are the dampers and blowers. Very, very simple system. About as simple a system as CSP can be. Then we have another proprietary technology that is a small turbine made by Capstone Corporation that converts this high temperature ambient pressure air into electricity and also process heat as needed without combustion or emissions. It's also equipped with an external combustor that can burn almost any fuel, including e-fuels, solar fuels, hydrogen, so on, but even diesel. And in this manner, we can eliminate all backup systems and gensets and eliminate that need for a backup power plant of any size. This is an example of our system. It's 400 kilowatts. Actually, this one is 600. India's largest utility bought this system. It'll operate for 24 hours on a sunny day. The heliostats on the ground, of course, reflect their light up on top of the tower to our solar receiver. And some of it during the day powers our turbine, and some of it is stored in our thermal energy storage system. We provide everything except the heliostats. For every project, we issue an RFQ around the world to get the best heliostat for that particular application. We also have a product that is considered a long-duration energy storage product for industry. We've taken this special high-performance turbine that I described and combined it with our thermal energy storage system. And in this case, we heat the storage by using an electric resistance coil that converts electricity from any source to heat. And this is particularly useful for industry, which has multiple challenges. Not only do they need heat, but they also need electricity. And depending on their location, they may need a backup system and often use gensets or the grid, which may not be dependable. And this turbine I described can operate as a genset in that sense, a backup system that keeps that industrial operation going even during the worst weather and grid challenges and so on. This is an example of the application in a mine. Here, the wind and the PV charges our thermal battery, our storage right here, and our turbine right here. And the results are really sensational. The cost of ownership plummets compared with using conventional gensets powered by diesel. Now, what most people ask is, how does our turbine work? Because, how do you drive a turbine without combustion? Well, it's not very easy, actually. In this case, we removed the combustor and replaced it with this high temperature heat exchanger. And we can take heat from any high temperature source, a factory, thermal storage system, or our CSP system, and put it through the heat exchanger, which acts as the combustor by heating to full turbine inlet temperature, the air coming from the compressor. And it puts off two sources of exhaust. One at 640 degrees, and the other at 250 degrees. In the case of CSP and thermal storage, this airflow goes back to the thermal storage or the concentrated solar system for reheating. Obviously, a system like this that produces high quality electricity and heat has many applications. And we're working with partners to develop those applications as turnkey systems. And here I should just emphasize that this is modular. Unlike most CSP, but we've also seen both Heliogen and Raygen this morning that have also gone the route of modular systems, which we believe strongly in. And the principal advantage, of course, is that most of the components can be made in factories and get the benefits of mass production, driving down costs quickly. And they're also scalable. In our case, in addition, because of its really incredible simplicity, we need no operators on our site. It's all operated and monitored remotely. So for desalination, a standard 24/7 solar plant is 600 kilowatts and 900 kilowatts of heat. We use most of the electricity for reverse osmosis and most of the heat to drive either MED or MFD or MSF, all of which are primarily heat driven. And this combination for this size system will produce about 4,500 cubic meters of clean water per day. We have a great team, deep experience, talented people, A professor at MIT was my co-founder. Unfortunately, he's passed away. And we have a great advisory board. So thanks again for this opportunity to talk with you all and to be part of this really quite extraordinary desalination seminar.
Thank you, Bruce. Always it is a pleasure to hear about your company, especially that you mentioned your technology is scalable. This is very important, and that's what we're looking for. Thank you very much for your time.
My pleasure.
Now let's go for our Q&A sections. It's going to be led by Mr. Frank Dinter, General Manager of Fraunhofer, Chile, and also he's the President of Board of Directors of ACSP. Frank, are you there?
Yes, I'm here. Thank you very much, Cristian.
Yes, thank you for joining us. And please, Johnny, Borja, Mr. Ocave, Carla, Jose, and Bruce, can you open your camera, please? We have some questions that we will be receiving during your presentation that Mr. Frank is going to share with you. Thank you.
Thank you, Cristian, for the nice leading through all these presentations. And thank you all the speakers for these beautiful, really great presentations. Our topic today is desalination and CSP. And as Johnny and also Jose already mentioned, the DNI is espectacular, so specularly in the north of Chile. And we have also a lot of industry, the mining industry in the north. So there is a good combination between electricity use and the demand of the mining. But we also have a water scarceness in the north of Chile. So desalination is really an important topic, having all this in the north of Chile. And with this, we saw there are different technologies in desalination which are used already all over the world. It's reverse of osmosis, and which is powered by electricity. And the other thing is the thermal desalination, while the energy comes from the cold end of the turbine instead of having a condensator. So these are the two technologies we have, and it's very important to say that Cosin Solar is building big plants in China, and they are continuing and pushing CSP. In other places of the world, it became a little bit quiet about CSP. We have one plant, it's Cerro Dominador, and it's a 100 megawatt plant built by Abengoa and Acciona. And but this unfortunately was not operating during the last year because of some issues. But the technical issues can be solved soon, as I understood from Cerro Dominador. And they are discussing with their EPC. So saying all this at the beginning, I really would like to start to question a few things. I would like to start with Carla. Carla, there from your side, you showed us a very nice technology. You have already a 5 megawatt demonstration plant, and now you are looking for a 150 megawatt plant. Can you tell us maybe the LCOE of this plant, and how are you going to integrate the desalination, for example?
Yes, so in terms of the LCOE, we have done some modeling based on specific assumptions. At the moment, we're looking at a range between $85 and $110 per megawatt hour. That is the first part of the question. And the second part of the question, our technology is also modular. So as I said before, we started with a 4 megawatt, but it's 17 hours storage. So the beauty is on the extending the energy storage at very low cost. And for providing the 24/7 green base load, ideally to the desalination plants, no matter the size, the technology can be modular. We can start with 30 megawatts. That is kind of because of the capacity of the ORC, the block that we're looking at the moment, and it can expand as much as required.
Yeah, and the LCOE, can you say any specific numbers for the electricity production of your plant if you're just going electric?
I mentioned $85 to 110 megawatt hours.
Oh, sorry, I didn't get it. Thank you very much.
That's the first part of the question. That's okay, no problem.
Okay. I just saw that Bruce has to leave early. Bruce, we know us a very long time from Solar Paces conferences and so on, and you are a big developer and a guy who is pushing CSP. Now we saw all your slides and what you are doing and in which direction it is going. Do you have any demonstration plant in this case?
We were trying to raise money to build our demonstration plant in Arizona. Money is really hard to find to build a new technology of this scale. And gratefully, NTPC, India's largest utility company, approached us during the pandemic and said, we have a serious problem, and that is that when the sun goes down, all the PV goes down, and we have to turn on coal plants. We're building them like crazy, and we've got to solve this problem. So we are about to break ground on our first full-scale system. Everything else is proven, all the different elements and subsystems, but this will be the first time that the complete system will be built and operational.
Yeah. Okay, so you're looking for money, so maybe Mr. Okabe would be a good fit to your financial issues in Arizona. So you should talk to each other.
We won't be building that. There's no need to build it anymore in Arizona because we have a super reputable first customer, and we'll prove our technology there.
Okay. Abengoa told us, Cox Abengoa told us that they are invited in a lot of CSP plants. It was mainly parabolic troughs in Spain and all over the world, and in South Africa and in Dubai. And well, they were also the EPCs for Cerro Dominador. From my perspective, Borja, can you explain how you want to integrate the desalination in such plants? Bye-bye, Bruce.
Thank you, everybody.
Well, it's not directly integrating something in something, because I believe that the solution has to be integrated from the design standpoint and from the beginning. So now, depending on where the plant is located, we cannot put a desalination, and because not always in all the cases the plants are close to the sea. So I think that obviously the integration of and the validation of the technology has to be done from the conceptual and basic and engineering and from the design, preliminary design of the plant. So it has to be all together. It's true that in some cases we can put a CSP somehow into a existing desalination, but I mean, make no sense. I mean, for me, and maybe I can be wrong, and some of the colleagues can add more details if any. But for me, the concept of this hybridization between desalination and CSP and more things, and as I mentioned in my presentation, has to be done from the conceptual, design and brainstorm and concept,
Yes. As I was working since many years in CSP, I know that in Spain, in the Plataforma Solar de Almería, they also approved the technology of thermal desalination. And me as a professor at University of Chile, we worked together on desalination, and we put a CSP plant next to a pipeline from the coast to the mines. There are where we have lots of sunshine, and we installed especially or theoretically, it was a study, it was not a real installation, but we worked on that to have a desalination plant at the pipeline. And we came also to very good values in electricity production and using the heat for desalination. So there's also a publication on this by a Chilean student, which was working together with Professor Rodrigo Palma from the Center of Energy at Chile, and me, especially on that topic. So I think these are very nice opportunities, and we should continue in this direction. We are already a little bit over the time. Christian, do we have to close, or how are we going to continue?
If you have 5 minutes, there's no problem. Is our speaker could join us for 5 minutes more?
Yeah, okay, fine. Maybe Johnny, you have the chance to tell us which are your really focused systems here in Chile. What would you like to do in Chile? Please tell us. Johnny, are you there?
Yes. Yes. As I mentioned, our main business is the CSP part, and we think in Chile now has the opportunity to develop a new CSP and PV, this kind of hybrid system. And we see the market the price of the PPA now is going up in the last years, and with the current level of the PPA price, and it's possible to develop a new CSP. Yeah, and we just need to also convince the developer the reliability of the technology, and also to work on all the project development. And for the water desalination part, yes, just as you mentioned, yes, I think it also has good opportunities for the water in the north of Chile, mainly in the inner part. Some areas, the water is very expensive. It could be more than $5 or even $7 per cubic meter, because they desalinated the water from the shore, and they deliver the water to the inner land. But we can actually build the desalination plant not on the seaside, just in the inner land, and so use the solar resource to provide electricity, to provide the steam to get the water desalination. I think can have a good price of the water. And also, as I mentioned, there's many solar or chemical production. They use the natural evaporation to get the mineral, and so a lot of water, huge amount of water, is just lost and in the air. So it's also possible to recover that by the CSP. Yeah.
Thank you very much, Johnny. Yes, and as for example, SLB and also Heliogen And as Bruce from 24/7 CSP told us, there are many possibilities in modular plants. And especially with this, we have a good chance in Chile to desalinate water and to produce electricity on the same place. And it should be inside the country, not at the coast, because the sunshine is not so good at the coast. We know about this. So thank you very much, all of the speakers again, and I will hand over to Cristian for the closing remarks.
Thank you, Frank, for leading our Q&A. As you mentioned, thank you for joining us, Jose, Bruce, Borja, Johnny, Mr. Okabe, and Mrs. Carla. Thank you very much for joining us. We have more questions, but due for the times, we are going to answer them directly by the person who been asking for. Thank you for being us, and on behalf of ACSP and ACADE, thank you very much. And we